Alright, today we are going to talk more about solving exponential and logarithmic functions. Alright, it says, as mentioned in exercise 52 of section 3.4, the Richter scale magnitude R of an earthquake is R equals the log base 10 of A over T plus B. A is the amplitude in micrometers of the vertical ground motion at the receiving station. T is the period of the associated seismic wave in seconds, and B accounts for the weakening of the seismic wave with increasing distance from the epicenter of the earthquake. The severity of an earthquake is measured by its associated amplitude. So what you do if you're going to compare or whatever earthquakes is you take the difference of the Richter scales and to figure out the ratio of them, you do log base 10 of that ratio. So basically, to figure out this ratio, you roll the log, 10 moves over, and it's going to be to the difference in the Richter scales. Alright, so it says, how many times more severe was the 2001 earthquake in something, India, where the Richter scale was 7.9, than the 1999 earthquake in Athens, Greece, where the Richter scale measured 5.9. I'm going to go through the long, drawn-out proof of what the shortcut I just showed you was, okay? So basically, if we use our formula, I could set up an equation that says, for India, his Richter scale is the log of the amplitude over the T plus B, yeah? And I don't know what any of that stuff is, but I don't care. I can set up the equation for the one in Greece, same thing, yeah? And then I can combine these, right? I could do subtraction, so I'd have R1 minus R2 equals all of this minus all of this, correct? Then what I can do is replace my R1 and R2 with what they told me. R1 was 7.9, R2 was 5.9. And then I start simplifying the other side, or I'm sorry, 7.9 minus 5.9 is 2. All right, then if I distribute this negative, I get a negative log and a negative b, right? Well, then what happens is this positive b and this negative b cancel each other out. So now I have this log minus that log. All right, so then remember to put your logs back together. I can undo subtraction. I can turn it into one log by dividing this by that. Okay, so then I can say that keep, change, flip, right? And here the t's are going to cancel. So that leaves me with log of a sub 1 over a sub 2. And then to figure out what this is, because I'm comparing the two, I want to roll the log away, which will move the 10 over. So that gives me 10 squared equals this, which means the comparison is 100 times more severe. I can't pronounce that word, but his earthquake was 100 times more severe than Athens. Okay? Now, what I'm saying is, instead of doing all of this every single solitary time, because this is always going to come out the same. I don't care. I mean, I could have figured out these values and plugged them all in and done all the math, but I don't care what this is. This is always going to happen. It's always going to simplify down to basically this. So what you have to remember is, if I look at the same problem, all you have to remember is that when you're comparing two different earthquakes, subtract their Richters, and that's going to be equivalent to log base 10 of a sub 1 divided by a sub 2. Okay, so I would... And what that means is the 10 moves over, so I end up with 10 to the difference in the Richters is going to be my comparison. So I figure out the difference in the Richters was 2. Plug that in for right here. Roll the log. Move 10 over, so I have 10 squared equals 100. I don't need to do all of that other algebra because it's always going to simplify down to the same thing. Alright, so let's try this one. It says, how many times more severe was the 2005 earthquake in somewhere over the rainbow? Really? with a Richter scale of 6.8 than the 1995 earthquake in everywhere but here. That's kind of cute. Where its Richter was 3.3. So all we have to do is set up our little formula. We're going to subtract 6.8 minus 3.3, and that's going to give me 3.5. So I have 10 to the 3.5 equals that, and that 10 to the 3.5 is approximately 3,162. So somewhere's earthquake was 3,162 times more severe than everywhere's. Alright, you try this one. Come back when you're ready. And hopefully you got 2. Alright, so we have an 8.2 on the Richter and a 3.6 on the Richter, which gives me 4.6. So I have 10 to the 4.6 equals my a sub 1 over a sub 2. If I type in 10 caret 4.6, I get the 39,811 if you round. Okay? Alright, chemistry. The acidity of a water-based solution is measured by the concentration of hydrogen ions in the solution in moles per liter. The hydrogen ion concentration is written as H+, because such concentrations usually involve negative powers of 10. Negative orders of magnitude are used to compare acidity levels. The measure of acidity used is pH, the opposite of the common log of the hydrogen ion concentration. So, more acidic solutions have higher hydrogen ion concentrations and lower pH values. Alright, so it says some especially sour vinegar has a pH of 2.4 and a box of leg and sickle baking soda has a pH of 8.2. It says, what are their hydrogen ion concentrations? Well, here's my formula, and they're giving me the pH. The vinegar's pH, they told me, was 2.4. So that equals the negative log of the hydrogen ion concentration, whatever. Alright, so if I'm trying to get this alone, because that's what it's trying, I'm trying to figure out what that is, so I want that alone. So the first thing I'm going to do is divide by that negative, and that gives me negative 2.4 equals log of the hydrogen ion concentration. If you want to get rid of the log, roll it away, but that's going to make its base move over. So that's going to be 10 to the negative 2.4 equals the I can't say that word, hydrogen ion concentration of vinegar. Alright, so 10, and I'm just going to leave it like that for right now. So now let's do baking soda. To do baking soda, it says it has a pH of 8.2. So 8.2 equals negative log of H+. Again, divide by a negative. Negative 8.2 equals log of H+. Roll the log, and 10 moves over, so I have 10 to the negative 8.2 equals H+. So now to compare them, I'm going to take the H+ of vinegar, which is 10 to the negative 2.4. Dang it. 10 to the negative 2.4 over my hydrogen concentration of baking soda, which is 10 to the negative 8.2. And since the bases match, you can keep the base and do the top minus the bottom. That turns positive. Negative 2.4 plus 8.2 is going to be 5.8. So 10 to the 5.8, right, is B. And then C says, by how many orders of magnitude do the concentrations differ? And the hint says, what does the exponent represent? The difference in the concentrations, doesn't it? So, approximately 6 orders of magnitude. Okay? Alright, so you try this one. Hit pause, come back when you're ready. It says if X is the hydrogen ion concentration of a sample of water, then the pH of that water sample is, again, my negative log of X. They're just saying that, and this side represents the pH, and this is they're writing it like this, but you know that side represented the pH, and this represented the hydrogen ion concentrations. Anyway, it says the pH from the water of one lake is 4.9. And the pH of the water from a second lake is 5.3. How many times greater is the hydrogen ion concentration of the second lake than the hydrogen ion concentration of the first lake? Alright, so you're going to do divide by the negative. Roll the base, so 10 to the negative 4.9. Divide by the negative. Roll the log, so 10 to the negative 5.3 equals X. And to figure out how many times greater in the hydrogen ion concentration of the second lake than the first lake. So the second lake is 10 to the negative 5.3. No. So to compare them, you put 10 to the negative 4.9 over 10 to the negative 5.3, and that's going to give me 10 to the negative 4.9 minus a negative 5.3 turns positive. Negative 4.9 plus 5.3 is 10 to the 0.4, and if I do 10 caret 0.4, I get 2.51188, blah, 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 blah. Whoops, what did I do? What, did I do it wrong? If we did it this way, because that's what threw me. It said the second compared to the first. That'd be 10 to the negative 5.3 minus a negative 4.9. Negative 5.3 plus 4.9 is negative 0.4. That's it. Silly goose. I should have trusted myself. Alright, it said the second lake compared to the first lake. So second lake had to go on top. First lake had to go on bottom. That gives me 10 to the negative 0.4, which if you type that in is 0.398107. They rounded it to two places. That bumped it up to 0, which bumped that up to 4, which is 0.40. Oops. Alright. Newton's law of cooling. It says an object that has been heated will cool to the temperature of the medium in which it is placed, such as the surrounding air or water. The temperature T of the object at time T can be modeled by this function. For an appropriate value of K, where T sub m is the temperature of the surrounding medium. T sub naught is the initial temperature of the object. So this model assumes that the surrounding medium, although taking heat from the object, essentially maintains a constant temperature. In honor of English mathematician and physicist Isaac Newton, this model is called Newton's law of cooling. So what you do is they're going to give you the temperature of the medium and the initial temperature, and you're going to plug that in to here, and you're going to plug in the given temperature, the y-coordinate, and the time, and you're going to solve that for K. Alright, so then it says find the equation for your data. Plug K into the equation from step 1 and use the equation to answer the question posed. So here we go. It says a hard-boiled egg at temperature 96 degrees is placed in 16 degrees water to cool. 4 minutes later, the temperature of the egg is 45 degrees Celsius. Use Newton's law of cooling to determine when the egg will be 20 degrees Celsius. Alright, so first thing, here's my formula. The temperature of the medium plus, the final temperature will be the temperature of the medium plus the initial temperature minus the temperature of the medium times E to the negative KT. Okay, so first of all, I've got to figure out K. So step 1 says plug in Sorry, I'm trying to change colors here. Plug in T sub m and T sub naught and simplify it down. So the temperature of the medium is 16 degrees because that's what you're going to place it in to cool. That's the medium that you're going to put the egg into to cool. So the temperature of the medium is 16. The initial temperature of the egg is 96. So minus 16, that's going to be e to the negative kt. So if I simplify that, 96 minus 16, I get 80. So far I have 16 plus 80e to the negative kt. Step 1 is done. Then it says plug in the given temperature for the y-coordinate and time, that will be the x-coordinate, and you plug them in here and we're going to solve it for k. Plug in the given temperature. Yeah. Sorry, so then the first, to figure out K, I've got to use this other piece of data. It gives me a time and a temperature that I can plug in to figure out my K. Because remember, if I want to figure out K, I've got to have everything else replaced. So I've got to replace this and this, which is why they're giving me this 4 minutes later, the egg was 45 degrees. So if I change the final temperature to 40, I want my final to be 20, but to figure out the rate at which this thing is cooling, I have to plug in some data point. So 4 minutes later, the temperature was 45, so that would be 16 plus 80 e to the negative k times 4. So if I got to solve for k, I got to isolate this. Okay, so the first thing I'm going to do is subtract 16. So 45 minus 16 is 29 equals 80e to the negative 4k. Now to get the e alone, I'm going to divide by 80. 29 divided by 80 is 0.3625 equals e to the negative 4k. To get your variables in the air, to get letters out of the air, you use logarithms or natural logarithms. So I'm going to natural log both sides. Alright, and if I type this in, natural log of 0.3625, I get, need more room, so I'm going to come up here, negative 1.015 if I round. On this side, these match, so they cancel, and that side becomes negative 4k. So to get k, I'm going to divide by negative 4, and k equals that divided by negative 4 is 0.254. So now if I write my function with my k plugged in, I have the final temperature will be where am I at? 16 plus 80 e to the negative 0.254 t. Yes? So there's my function for, in this situation, how fast that egg is going to cool. So now I can figure out how much time. I knew it took 4 minutes to get it down to 45 degrees. Now they're asking me how much time is it going to take for it to cool down to 20 degrees. So now I know what I want my final temperature to be is 20 equals 16 plus 80e to the negative 0.254 t. And I'm trying to solve it for t. So again, I'm going to subtract 16. That gives me 4 equals 80e to the negative 0.254 t. Divide by 80. and I get 4 divided by 80 is 0.05. Again, I need more room always. So I got 0.05 equals e to the negative 0.254 t. T is in the air, so I need to take the natural log of both sides. ln of 0.05 is negative 2.9957 yada 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 equals, that cancels, and I got negative 0.254 t. Divide by negative 0.254 divided by negative 0.254, and I get time equals 11.8 minutes. So it takes 4 minutes to go from 96 to 45. It'll take almost 12 minutes to go from 96 down to 20. Okay. Alright. You do this one, hit pause, come back when you're ready. And hopefully you got 37.6 minutes. Alright, so a cake is removed from an oven at 325. That's your initial temperature. Cools to 150. That's one of your final temperatures after 25 minutes in a room that's 68. That's the temperature of your medium. How long will it take to cool to 114? So the first thing we're going to do is set my function up with all of this information. I'm going to skip a step that I did last time. I'm going to simplify a couple things at once. So I have my final temperature was 150, and that equals the temperature of my medium, which was 68, plus my initial temperature was 325, minus the temperature of my medium is 68, times e to the negative k, and it took 25 minutes to do that. So if I solve this thing for k, I have 150 equals 68, 325 minus 68, plus 257e to the negative 25k. So if I isolate, I'm going to subtract 68, 150 minus 68 is 82, equals 257e to the negative 25k. Divide by 257, divide by 257. I get 0.31906 blah 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 equals e to the negative 25k. I got my variable in the air, so to get it down I'm going to have to natural log both sides. So ln of that is negative 1.14 blah 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 equals, these cancel, negative 25k. Divide by negative 25, and k equals 0.0457. So now if I write my function, I have the final temperature will be the, where am I at? Right up here. So it'll be 68 plus 257e to the negative 0.0457 t. And now I can use that equation to answer the question, how long will it take to cool to 114? So I want to know the time when the final temperature is 114. 68 plus 257e to the negative 0.0457 t. Again, I'm going to have to isolate so that I can ln it. So minus 68, 114 minus 68, I get 46 equals 257e to the negative 0.0457 t. Divide by 257, divide by 257. I get 0.17899 or whatever equals e to the negative 0.0457t. My variable's in the air, so I'm going to have to natural log to get it down, both sides. The natural log of that mess is negative 1.72, yada, 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 equals, that cancels, negative 0.0457t. So to solve for t, divide by negative 0.0457, negative 0.0457, and the time is divided by negative 0.0457, 37.646, which rounds to, well, that was a 4, so that would round to 37.6 minutes. Yeah? Alright, so how do you apply the properties of logarithms to solve application problems? Well, look at what we did. We had to isolate and use natural logs to solve, right? We set up equations that involved logarithms, and then we got x alone. Alright, so we are at homework, which means we are done. So happy homeworking, and I'll see you next time.